Welcome to this explainer. Today we're going to do something a little bit different, a little fun. I want you to imagine we've just stepped off campus and into a university lecture hall. I'll be your enthusiastic economics professor for the next few minutes, and I am absolutely thrilled to introduce you to the fascinating, mathematically rigorous, and, honestly, sometimes deeply perplexing world of international trade theory. We are going to explore a foundational framework that attempts to explain exactly how countries trade, why they trade, and what actually happens to the people inside those countries when borders open up to global commerce.
So to kick things off, let me pose a bit of a Socratic question to you. It's one that really establishes the massive, real-world stakes of the theory we're about to unpack. Does free trade equalize global wages? Just think about that for a second. If a wealthy, highly developed nation opens up free trade with a developing nation, is it an inevitable mathematical certainty that the wages of workers in both countries will eventually just match? Could free trade directly impact your wallet, regardless of whether you personally ever cross a border?
Here is our mental syllabus for today's session. We'll start with the factor price theorem, then move into the Heckscher-Ohlin model, outline our core model assumptions, map out how we get from goods to factors, and finally, confront the real-world paradox.
All right, let's dive straight into part one, the factor price theorem.
Okay, let's dive right into this monumental breakthrough. Back in 1948, the legendary economist Paul A. Samuelson formalized what we call the factor price equalization theorem, or FPE. And it makes an incredibly bold claim. It states that when countries engage in totally unrestricted free trade of commodities, the prices of the inputs used to make those commodities, things like the wages of labor and the rent of capital, will completely equalize across those nations. The brilliant, frankly counterintuitive part of Samuelson's theory is that these wages and rents can equalize worldwide without a single worker migrating and without a single dollar of capital crossing a border. The simple act of trading goods acts as a perfect substitute for the physical mobility of labor and capital. It's kind of mind-blowing when you think about it.
Now, to make sense of that, we need to look at part two, the Heckscher-Ohlin model.
To understand exactly how Samuelson arrived at this profound conclusion, we have to lean on a foundational framework developed by Swedish economists Eli Heckscher and Bertil Ohlin. In economics, we absolutely love simplifying the infinite complexity of the real world into nice, manageable models. The Heckscher-Ohlin model relies on a classic textbook setup known as the 2x2x2 framework. We just imagine a world with exactly two countries, let's call them home and foreign. They produce exactly two goods, let's say cloth and food, and they use exactly two factors of production to make these goods, labor and capital.
Now here is the absolutely crucial part, how these two countries actually differ. In this model, they don't differ in their intelligence or their technology, but rather in their natural endowments. Let's say our home country is labor abundant but capital scarce. It has a massive workforce but very few machines. Our foreign country is the exact opposite. Capital abundant and labor scarce. Heckscher and Ohlin theorize the comparative advantage is driven purely by this relative factor abundance. Basically, a country is going to export the goods that intensively use the factor they happen to have in abundance.
But as we move into part three, we really need to talk about our core model assumptions.
As your professor for the day, I've got to issue a pretty strict warning here. To make this beautiful FPE math work out perfectly, we have to play inside a very strict, tightly bounded intellectual sandbox. We have to methodically enforce our assumptions. We assume perfect competition in both product and labor markets. We assume constant returns to scale, meaning if you double the inputs, you get exactly double the output. We assume absolutely zero transport costs and zero tariffs. Zero. We also assume factors are perfectly mobile within a country, moving seamlessly from the food sector to the cloth sector while maintaining full employment. Oh, and no factor intensity reversals. Cloth is just always labor-intensive everywhere.
I really want to highlight one specific assumption, though: identical production technologies. This means a worker in the home country has to be able to use a piece of capital to generate the exact same output as a worker in the foreign country. This implies identical knowledge, identical workforce habits, and identical organizational abilities. I cannot stress this enough. This assumption is the crucial, highly fragile linchpin holding the entire theoretical model together.
Okay, moving right along to part 4, from goods to factors. So, we've built our sandbox, but how does this machine actually work in practice? How do we get from just trading cloth and food to literally equalizing global wages? Well, the mechanical logic is actually pretty elegant. When a labor-abundant country opens up to free trade, it starts heavily exporting labor-intensive goods, like cloth. Think of trading goods as just an indirect way of trading the underlying factors embodied within those goods. As our home country exports more and more cloth, the domestic demand for labor naturally skyrockets to meet production. In a perfectly competitive market, as demand for labor rises, wages are naturally bid up to attract more workers. Simultaneously, output prices for the goods themselves begin to equalize across the trading nations. And because of those very strict assumptions we just laid out, that equalization in the price of the good mathematically forces an absolute equalization in the price of the inputs.
Now, what's really interesting here is how this classic relative factor price equalization curve visually proves the math. On the horizontal axis, we've got our relative factor price. That's the wage divided by the rent. On the vertical axis is our relative commodity price, the price of good X divided by good Y. Because of our perfect competition and identical technology assumptions, there's a perfect, continuous one-to-one relationship happening here. When free trade forces the commodity prices on the vertical axis to align between two countries, they are forcefully dragged to the exact same point on the horizontal axis. The wages mathematically have no choice but to equalize.
And that brings us to our final section, the real-world paradox. Now it's time to drop the hammer and conclude our lecture arc. Because what actually happens when we take Samuelson's flawless algebraic proof out of the pristine classroom? Well, we slam right into reality, specifically something famously known as the Leontief paradox. In 1953, economist Wassily Leontief tested the Heckscher-Ohlin model using actual data from the United States. At the time, the U.S. was the wealthiest, most capital-abundant nation on Earth. According to the theory, the U.S. should obviously export capital-intensive goods and import labor-intensive goods, right? But Leontief made a shocking discovery. U.S. exports were actually less capital-intensive than U.S. imports. It was literally the exact opposite of what the theory predicted. And the data we're looking at here brilliantly illustrates the depth of the problem. When later economists ran multi-factor tests of the model across dozens of countries to see if relative factor abundance accurately predicted trade, the results were, frankly, dismal. For capital, the predictive success of the model was essentially 0.52. For managerial workers, it was an abysmal 0.22. For predicting the flow of capital, the grand Heckscher-Ohlin theory was basically no more accurate than just flipping a coin.
So, where did we go wrong? Remember that fragile linchpin assumption I warned you about earlier? The one about identical production technologies? Yeah, data from 1983 totally shatters it. If we set the United States' technological efficiency at 1, West Germany was at 0.78. But for Bangladesh, its technological efficiency was a mere 0.03. The core assumption that all countries share identical production capabilities, habits, and organizational structures was just fundamentally flawed from the start.
To summarize our findings today, perfect factor price equalization largely fails in the real world simply because our perfect little intellectual sandbox doesn't actually exist. We have vastly different technological and productivity efficiencies across borders. We have massive ocean freight and transport costs. We have political tariffs. And we have what economist Daniel Treffler famously called the missing trade phenomenon, meaning countries simply don't trade anywhere near the volume of factor services that their endowment differences suggest they mathematically should.
Which leaves us with one final provocative thought to wrap up today's explainer. We all know a growing wage gap exists in many advanced nations between skilled and unskilled workers. But if the pure academic models fail and international trade isn't perfectly equalizing factor prices, what is actually driving that divide? Is the villain truly free trade and globalization, or is the true culprit the relentless, unequal march of technology favoring highly educated workers? Class dismissed. But I really hope you leave here today eager to investigate that exact question.